All right. Well, this is going to be your video to hopefully help you recap and remember some of the things that go into the experimental design part. This is a challenging part. It's worth a lot of points. So I wanted to make sure I went ahead and gave you some review materials to go back and just make sure that you understood. The main focus of this is going to be the variables, because I think that those are the most difficult parts. But if you remember, like part of this is just listing the question. There's also a component on there with a hypothesis. And remember, as long as with the hypothesis, you go ahead and you list the if then part of it. So if I do this, then this will happen. You should be good on hypothesis. Now, the next part of this is identifying variables. Okay. And variables are just a part of every single experiment. Okay. Let me go ahead and scroll down to the actual variable table here to hopefully help remind you of some of the important things here. Okay, so here's what I need you to remember as far as identifying the variables. The independent variable is the thing within the experiment that is changing. Okay, so I like to give you some questions that I want you to ask yourself as you're looking at these different experiments. So the question that you should be asking yourself is, what is it that the scientist is changing? You are the scientist. So amongst your experiment, what is it that you are changing? Okay. And for this one, it wants you to go ahead and use what we'll call Mr. Tobin's experiment, which I use Mr. Tobin for this one. And that experiment is up here. And it says, Mr. Tobin has long wanted to be a farmer. He bought some land in Africa and is attempting to grow his favorite tree, the baobab tree. Mr. Tobin is failing miserably at being a farmer, and he needs your help. Help him come up with an experiment that will help him decide what kind of fertilizer, if any, he should use to grow the tallest trees. So we're going to use either 5% nitrogen, 10% nitrogen, 15% nitrogen, or 20% nitrogen. You must include a list of materials and detailed procedure on how to conduct it. Okay. We skipped down and we went straight for the variables. So you ask yourself, Mr. Tobin is the scientist. What is it that he's changing? Well, if you remember from up in that experiment, he is changing the percentage of nitrogen in his fertilizer. That was pointed out here. So what kind of fertilizer should he use? He has a 5% nitrogen, a 10% nitrogen, 15, or 20. That is clearly, Mr. Tobin is going to set up an experiment where he uses different types of fertilizer to test which one is best for his trees. That's what he's changing. Now, as far as the dependent variable goes, this is the factor within the experiment that will be affected by that change. A lot of people here get this one wrong. A lot of people like to say, okay, well, this is the one that stays the same. That's the one I hear all the time. The independent one's the one you change, and the dependent one is the one that stays the same. That idea is totally wrong. This is the one that is going to be affected by the change. So we just established that the change was going to be the fertilizer. So what is it that is going to be affected by that change? So you could ask yourself here, what is being measured or what is being affected by the independent variable? Well, Mr. Tobin is growing these trees. He's using different fertilizers on them. What is going to be affected by those different fertilizers? Hopefully the growth of the trees. So the dependent variable here is going to be the growth, because we can measure that, and the growth is going to be affected by the independent variable based on how much fertilizer we use. That's going to change how much growth these plants are experiencing. As far as some other things that you'll need to consider, things like constants. These are things that stay the same. These are things that do not change. So things like amongst all of your baobab trees, you want them to get the same amount of sunlight. You're going to want them to get the same amount of water. You're going to want them to get the same amount of trimmings, the same amount of pest protection, all these different things. You're going to want that to be the same, because the only thing you want to be different is the amount of fertilizer. Okay, that's it. Now, if you were doing this with some other experiments, let's take a look at another example here. What type of sunglasses blocks the most sun? You got all these different kinds. Well, what's the independent variable? How do we figure this out? Well, we're going to go back up. We're going to ask, what is the scientist changing? The scientist is changing the different type of sunglasses. Well, okay, we got a different type of sunglasses. Well, what's the dependent variable? What's being affected by that independent variable? In other words, what's dependent on the independent variable? And that is the thing that we can measure. And that is the amount of sun that gets through, the amount of light that gets through. Some things that we could remain constant. Well, you probably going to want to put it on the same face. Probably going to want to do this experiment at the same time of day so that the sun angle is equal, and you can kind of really tell how much sun is getting through. Those are different examples of constants, things that you want to keep the same no matter what set of sunglasses you're keeping on. Okay. All right. Hopefully this was very helpful as far as the variables and how to set that up. If you needed a little review on this, I hope this helped. Let me know, email, or we can take a look at it on Monday just to make sure that everybody is in a good spot. All right. See you guys.